Hi, I'm Peter Axelson, and I'm going to talk about preventing damage to mobility aids during air travel. I started my career in aeronautical engineering at the Air Force Academy in Colorado Springs, and I was in a training accident that resulted in a spinal cord injury. And so I was redirected into the field of assistive technology, designing adaptive equipment for sports and recreation initially. This hiking chair is one of the things I worked on the seating on, and then adaptive skiing allowed me to race on the U.S. Disabled Ski Team and teach as an instructor. And then meanwhile, I was testing wheelchairs back at our test lab for static stability and dynamic stability and durability here. We would run the chair for 200,000 cycles on frames like this, and then drop testing for thousands of cycles. Dynamic stability, the product sometimes falls over backwards like this case here, and we have to determine how to adjust the center of mass to make the chair safer. I was very blessed to be able to continue to fly using hand controls in Cessna aircraft as an instrument-rated pilot to be able to get to meetings in the Western US, on flying on longer flights commercially, getting on and off boarding chairs and experiencing the difficulty there with commercial air travel. And so I designed, modified my own manual wheelchair with additional wheels to get down the aisle on most commercial aircraft. But I realized that for powered chair users, um, extremely difficult circumstances of powered chairs, the drive wheels would get broken off, the entire seating system would get destroyed. So I started the development of an American national standard for assistive technology for air travel in the Rehabilitation Engineering Society of North America. Section 4 of that standard has to do with labeling and design requirements for a mobility device that is specifically designed for storage and transport in commercial aircraft. We assembled air carriers to participate in that work, to provide their input, and also wheelchair manufacturers and other wheelchair experts, as well as disability organizations representing all the people that use all different kinds of mobility aids, and various federal agencies, the Food and Drug Administration, DOT, the US Access Board, the VA. There's a lot of different wheelchairs this has to apply to, manually folding chairs, rigid and X-frame brace type chairs, manual chairs with complex seating that don't fold, manual chairs with add-on power systems and add-on power assist hand rims, standard powered wheelchairs with 4 to 6 wheels typically, and scooters with 3 or 4 wheels all have to be able to travel on aircraft. So I'm going to talk about the 3 sections here, the design requirements for those chairs, the labeling guidelines, and the air travel configuration card. For manual chairs, the chair needs to be able to fold up and have some kind of latch mechanism to be secured in a folded position so it's not damaged. And ideally, it's stored in a closet or an overhead or somewhere in the aircraft that can prevent loss or damage to that chair. The air travel configuration card has some key features. It's highly recommended for all powered wheelchairs. And at the top left corner is the air travel information symbol, and the top right corner is the symbol indicating compliance with the air travel standard. And then in the bottom right area is the unoccupied weight of the mobility device, as well as accessories and battery information, the primary instructions for preparing the mobility device for air travel, the images showing its chair in its air travel configuration on the left, with the back support folded down to a height less than 30 inches in this case, and then on the right, in its driving configuration. On the back side of the card is the location of the battery isolation switch on the chair, the disengagement levers on the chair, the lifting points on the chair, and the securement points for the chair. Also a QR code, which will be located on the wheelchair to pull up the air travel configuration card. or the wheelchair user manual would be available. Air travel configuration card formats have been designed for scooters as well as manual chairs as well. So let's see how this works in use here. We see a powered chair, 137 kilograms, and we see where the lifting points are. And these things enable the ground handlers to be able to lift this powered wheelchair up onto the belt loader for access into the baggage area of the aircraft. There are also various types of mechanical lift devices, in this case, lifting a scooter up to where it can just roll onto the belt loader device. Once in the cargo area, either the wheelchair securement points for transportation can be used, or slings can be put onto the wheelchair, or the cargo straps can be attached to the lower frame assembly of the chair. Section Annex G of the Air Travel Standard shows the locations of various securement points for powered chairs down on the lower base where it can be secured, and scooters where they can be secured down on the lower base, and also manual chairs securing to the frame. So this air travel configuration doesn't include just weight, it includes the size and the battery type. The length, width, and height are the important size elements, the height being extremely important to verify. In this case, the tilt mechanism on the wheelchair allows the back support of the chair to get down to a reduced height compared to its user height on the right there. The battery requirements, most important is that they're non-spillable. The symbol that's been developed here for the lock and fluid to be a locked battery with being non-spillable, the number of batteries, the chemistry, the access location, their voltage. And so a typical lead acid battery is required to be non-spillable for wheelchairs in the United States. There needs to be tool-free access to access those batteries to verify that they are indeed non-spillable. And then the 4 primary steps for preparing a powered chair for air travel: reduce the height of the wheelchair, remove components that can be stored in the aircraft, isolate the battery power, and then disengage the drive mechanism so the device can be pushed. If the chair can't reduce in height, it is often necessary to tip the powered wheelchair onto its side, and this creates a situation where the joystick in this case is very close to the engine there, and it's very important that this has to be up versus in the down position. So reducing the height allows the chair to get into an air travel configuration. So either removing, folding, or somehow reducing that height, tilting the chair in this case to get up into the baggage area where it can be reduced in height, and then to determine how to reduce the height for other chairs. If necessary, a user could use tools to enable the ability to reduce the height of the powered mobility device to fit into the aircraft. In this case, the seating system has had some pins pulled on it so that it can fold forward to allow it to roll up and into the baggage area of the aircraft. The second step for the air travel, of course, was removing the components. And this symbol here is the symbol for components that are removable with the latch mechanism. So things like the seat and the back and the head support and joystick would all be removed. The joystick assembly should ideally be removable without tools. It is required for an air travel ready wheelchair, and the electrical components detach with another connector. This allows the joystick to be kept inside the aircraft. If not, it's possible to use tools to remove a joystick assembly that otherwise may be damaged or lost. If it can't be removed, putting plastic containers around the joystick assembly is shown on the left here, or putting a container around the entire joystick assembly can allow the protection of that device. The third step is isolating the battery power, looking for that switch with this symbol here showing where that is. And on a powered chair, sometimes it's in the front or the back of the chair. And then if that's not available, disconnecting the connectors on the battery to actually unplug the battery adjacent to the battery itself. Final step, disengaging the drive system, looking for this symbol to separate those gears, just like putting a automobile into neutral so that you can manually push that chair. There's 2 disengagements on most powered wheelchairs, and then 1 disengagement lever on all scooters. So when will these chairs that meet this air travel standard be available? Well, there already are a couple of products that fully meet the AT1 standard, and the manufacturers, major manufacturers, are all working on models of powered wheelchairs that will meet this air travel standard to be less likely to be damaged. So I appreciate this opportunity to share this information with you, and you can reach me at peter@beneficialdesigns.com, and I'll be happy to answer any questions. Thank you.